Good morning, Satoshi-san, and thank you very much for joining in this conversation. Kyoto Fusioneering was one of the first winners at SusHi Tech Challenge. So essentially, we are looking at SusHi Tech Tokyo, which is starting next Monday, and basically trying to understand the startup ecosystem in Japan. So in that respect, Kyoto Fusioneering was the first winner of the SusHi Tech Challenge about 4 years ago. Looking back, how did that moment influence your company's trajectory in terms of visibility, partnerships, credibility over these last 4 years?
Yes, thanks to the current environment and also that it was kind of lucky that our strategy is now well understood by our customers and our just colleagues in the fusion industry, not only in Japan but in the world. That our strategy is very simple to assist any fusion developers in the world with the fusion technologies. Based on our research in the previous years and also the Japanese and industries to just connect each other to integrate and to establish the fusion supply chain. And because fusion is the various kind of the top level technology to make one device for any kinds of the fusion challenges. So we have to organize the suppliers to make the fusion devices to respond to the very high end technical requirement. And so far now we have been successful to work with our customers, not only the private companies but also the public sectors. And I believe that our strategy is now strongly supported and appreciated by the fusion community in the world.
Right. So, your current customers are they in Japan or are they overseas as well in other countries?
Both, but I have to say that the majority of the customers located in the other countries than outside of Japan.
Right. So, at the time you started and you won the SusHi Tech Challenge, I mean, fusion energy was still seen as a long-term scientific ambition. Even now, I think commercialization is still not reached that level. So, what gave you the conviction that it could become a viable startup business?
So this is a little just maybe different from the views by the other fusion developing countries and development companies in the world, because we still see lots of the technical issues, technical challenges that to overcome in the coming years. But the understand that the fusion energy is not just a faraway dream, but a realistic challenges that should happen, that should be overcome every year. And that is the source of our business. Yes, we still have to make a lot of technical challenges, and sometimes we would fail, and we have to correct the problem and make our devices better. And now we are certain that eventually that we will make the fusion energy real within 10 or 15 years from now. But we need technical challenges anyway.
Right. So, do you think that fusion technology is probably going to be the answer to the world's energy problems?
At least that is one of the candidates. And without fusion, that it would be a little more difficult for humankind to overcome the current just energy and the environmental problem. That the energy supply still needs a lot more energy supplies, and that the logistics and supply chain of the energy to the energy consumers, that would be not only in the industrialized countries but also in the developing countries. There will be so many the energy demands in the world. At the same time, we have to decrease the carbon dioxide emission, and also that we are seeing the current situation of the Hormuz and the Strait, and this oil supply problems, that we have to have a real robust and abundant and also stable energy sources, and not based on the resources but based on the technology. So that is our understanding. I do not say that the fusion could be the only one possible solution, but certainly this is one of the very preferred candidate. And we see that the fusion, if it would be real, that we will solve at least the energy and the environmental problem.
Right. So, can you describe your company's evolution from being a research-led venture to, a commercial deep tech business? I mean, how did it evolve? Where did you start, and where is it now?
Our company started from Kyoto University, so this is just a spin out from the university experiment and the university research that is within a small, a little bigger than the usual, but still it is just a university scale. So we have to make it in the scale of the commercial technologies. So that we have to have a mechanism like a company to make the fusion devices a little larger with a sustainable business, with a supply of the resources and the working people, workforces, and getting money, and just run our business to provide the product that would eventually make the fusion energy. So that there was just a big gap from the university scale to the industry scale. So that is our mission. That we are still working on. We're still making our company bigger to make our production scale bigger and to make our technology to be better to respond to the requirement by our customers. But eventually that will make our technology in the quality and the quantity that will really respond to the real market demand for fusion energy. So that we are on the way. But we be that this approach is correct.
Right. So, your model focuses on fusion plant engineering rather than just reactor development. So, how does this position Kyoto Fusioneering differently within the global fusion ecosystem?
I'm very sorry that I don't really tell the difference between the fusion reactor and the fusion plant technology. That both are just a devices. That is a plasma device that have a very specific technology like a magnet or like a vacuum chambers. In the case of the inertial confinement, we need the lasers, but again, we need the chambers, but we need also the field cycle to feed the field and to recover the unburned fuel and return it again, and to breed the tritium fuel. That kind of technology is a part of the reactor to be sustainably operated. But anyway, the device is the device. We need the devices. Some are inner, some are outer, but the integrated system of the machine that would make a fusion reaction in the plasma core to be possible and to be sustainable is just devices with a very high level technology. So the way of working on this technology.
Right. So, Japan has always had very strong research capabilities, but historically struggled with commercialization. So,
Thanks.
what were your biggest challenges, in terms of translating your decades of research into a startup?
The big companies or the public sectors cannot try to challenge because they are responsible for the tens of the thousands of employees or the taxpayers, so that they cannot take the big risk. So they are conservative. Our challenge of a startup company is to challenge the high risk but high return technology, and as a small group to focus on high level of the technology, as well as collecting investment and challenge some unique technologies, the unique ideas, and to make innovation. So that is a challenge of the small startup companies to make innovation. So that is our role. We are not alone. We have several tens, maybe hundreds of the such kind of the technical challengers in the world, and some of us may be successful to make a real innovation, and then to take advantage that innovation that public, our society, our this industry can take advantage of this fast growth progress of the technology to be made by innovative companies. So that is our mission.
In your experience, how does building a deep tech startup in Japan differ from maybe doing so in the US or Europe, particularly in terms of funding, talent, and market readiness?
Thank you for the question. Yes, that exactly hit what we have a trouble is in the U.S. Probably the funding market, that the investors world is a little bigger and a little more easier. We still are working on the investment market to collect some tens of the millions, hundreds of millions of the investment to launch our new project. But Deep Tech Challenge needs money, and not only money. So we need research infrastructure. So we need a big area, a big testing site, some safety regulation, and that kind of things is then not affordable for small companies. And so money, we need money, but money itself does not answer the question. Thanks to the previous environment ecosystem in Japan, to make a small startup company spun out from the university had some advantages. We had a high level of the scientific research facilities in the public sectors and the universities. That we had high quality people that are working on the mostly science. Some are experimental, some are numerical and theoretical. But anyway, we had good people. And we had a good industry in Japan, and we had the infrastructures in Japan. So that was a kind of advantage in Japan. But to make it bigger scale is another story. We need a bigger money. We need support from the policy, from the government, and also we need a bigger infrastructures that has never been affordable for private sectors, and and also the we need to meet the requirement from the public and the regulations, and these kind of things are a little difficult. So that we are still struggling to collect a larger scale of the money, and we collect good people to make a new team to work in a new environment. And also that we are trying to take advantage of the previously developed research infrastructure, research platform based on the previous nuclear technology and other technologies to be reformed to meet the fusion specific requirement. That is slightly different. I understand that we do see the similar situation not only in Japan but also in Europe and the US and some of the Asian countries. That they have some good research infrastructures, mainly in the public sectors, and they have also good people. But again, to make a fusion industry, we have to reform the existing system to meet the fusion specific requirements. That is what is happening.
Yeah, so fusion is typically so capital intensive and long cycle by nature. So for when you approach investors, I mean, what is the kind of appetite they have? I mean, are they ready for such longer timelines and technical risks where technical risks are so high?
And that is a very good question. That is originally I understood that investment coming to the fusion would expect a very long time for the return of their investment, like a pension fund or like a public fund, because fusion needs decades to eventually make money. So it still needs a long time to go. But I found many of the VCs, the venture capital, also would like to have their investment return in 3 to 5 years. It's a short term, so that we have to ask the investors to understand our time scale is slightly different from very quick return venture capital's investment. So that we are now trying to communicate with not only VCs, but we are also trying to communicate a longer term fund, longer term investment, like big companies, they give the corporate, some are public, and some are long term, half public, half private, those kind of things. So that apparently that our Kyoto Fusioneering investors are now changing. And we still have original VC investors. They are renewing their investment, but also that we are looking at a longer term investors as well to support our business, our development. That will take another to 3 decades to go.
So, how important are platforms like SusHi Tech, when it comes to shaping global awareness about Japan's deep tech capabilities, particularly areas like fusion, robotics, and advanced manufacturing?
Yes, thank you. Is the framework, just single event to a long-term framework to support the communication, support the interaction between the different types of the investors and the industry partners and the startups, and they're essential because that we need a large-scale organization of the different types of companies getting together to establish a new industry, a new supply chain. Fusion itself is a very complicated system, and we take advantage of the existing ecosystem, existing industry of Japan that has been made a good success in automobiles and electric products and semiconductors. But fusion is not identical. We have to just make a different communication, different partnership to establish the new combination of the sponsors and the trading companies, supply chain companies, resources, and also the energy consumers and energy users. That there are very many possible chances for a new communication, new partnership, and the SusTech and that kind of that framework is very essential to organize this kind of new communication, new combination to uh, to establish a new industry. So I appreciate this opportunity very much.
All right. From a commercial standpoint, when do you see fusion becoming a meaningful part of the global energy mix?
Yes, of course, but that is more than that. If we would simply replace the current energy sources like oils and the coals, fusion, or with if replaced with renewables like a solar and wind, and it doesn't make sense. What we intend is a fusion is a very specific types of energy that does not need large amount of resources. It does not have a constraint of the natural environment like a physical location on the globe and the weathers, and so that we have a total freedom of the making energy system, not only energy supply but also the energy usage. That we may think about the direct conversion of the fusion energy not only to electricity but to a heat, or for the residential support, residential service, or to make industry like a petroleum based, so kind of combinations. And also that, for instance, if we would just run just a data center, data systems, the AI system combined with a fusion energy system, we do not have to just carry the large amount of electricity for a long distance. So that our new system of the fusion-based energy system would probably change the style of energy utilization by humankind. And so that would just reform this energy systems. We will no longer, if we just continue to run our, for instance, automobile-based transportations, if we would just have a cheap and easier oil and gas, and we will simply just make a larger number of the automobile than to fill the old highways in the world. That is a crazy idea. If we would have a new energy system, we will have a new transportation system, would have a better transport of the people and the goods and all the possible needs for the services. That is the possibility of the fusion. So the fusion, the possibility is not limited to the electricity supply, but to just make the energy supply and the consumption style of the humankind better and more environmental friendly. So that is my understanding.
Looking ahead, I mean, what does success look like for Kyoto Fusioneering over the next 5 to 10 years?
I believe that our understanding, our strategy to establish the fusion supply chain is the most important target for the next 5 to 10 years. And I believe that this understanding is now shared by the world fusion people, fusion businesses, as well as the private sectors. That is the good news. Bad news is that now that we would see this is another aspect of the geopolitical battle happening again. And the previous geopolitical battle simply is just a fought between the countries that fighting over the resources. But now that we are fighting over fighting over the technology. So that the technology the leadership, and then just is exactly what we are seeing in the space programs. We thought that the space is one of the very peaceful world that humankind can work together to develop the unlimited colonies over our globe. But in reality, some of the countries are now fighting on the moon to get the new resources. So the technology itself is not innocent. Of course, that we may be free from the resource constraint, but again, that the technology is another battlefield now. So that we have to collaborate, we have to have a better, more friendly, more intimate relation between the countries because we are now just collaborating for the unlimited source of the energy. But if we would go wrong way, that would be simply another battles to take a leadership on the technology. So, uh, so that I don't believe that the people, some of the big countries were fighting on the moon, no, the south pole of the moon. I don't like to see it would happen. So that I do not hope that we would have to just fight over the fusion technology world. But I'm afraid that that can go wrong way. So we have to be very careful.
Right. So, what are your expectations from Sushi Tech Tokyo this year? I mean, are you specifically looking forward to anything next week?
We are in Japan that the Japanese policy makers are certainly making a next big step toward the fusion energy. So the SusTech and yes, this kind of investor and the company communication on the fusion is going to the about one order of magnitude larger scale. In the previous year, then our size of the fusion development by private sector was some $100 million dollar equivalent. But now that we are looking at the 10 times larger technology, 10 times larger the scale of the development. So that our communication with the investor and between the companies would be a bigger. And SusTech would certainly be one of the good opportunity for us to make this kind of the business bilateral, trilateral, multilateral. That's communication that would be even bigger and even more important than ever.
So, on that note, thank you very much, Satoshi-san. I mean, we look forward to hearing more about Kyoto Fusioneering and the progress that you make in the area of fusion technology over the years. And I also hope to see you in Tokyo next week.
Yes. Okay.